Welcome everyone. I'm excited to kick off our presentation today. We'll be exploring data literacy, interpretation, and insight generation. This is part of our certificate in Analytics Foundations. Over the next few slides, I'll walk you through the key concepts and skills that will help you become more confident in working with data. Let's get started. Welcome to Slide 2. Here, we outline the agenda for our training. We'll start with Module 1, which is an introduction to analytics and data literacy, helping us understand the basics of working with data. Then, we move to Module 2, where we'll learn about different data types and sources, essential for understanding where data comes from and how to categorize it. Next is Module 3, focusing on how to collect, clean, and prepare data, crucial steps to ensure our data is accurate and usable. After that, we'll explore the foundations of descriptive statistics in Module 4, which help us summarize and understand data patterns. Module 5 is all about data visualization and storytelling, turning data into clear, compelling stories. Finally, in Module 6, we'll learn how to interpret data and identify meaningful patterns. This agenda sets the stage for our journey into data analytics, emphasizing practical skills and insights needed to harness data effectively. Welcome to Module 1, Introduction to Analytics and Data Literacy. In this part of the presentation, we're going to explore what analytics really means and why data literacy is such a crucial skill in today's world. We'll look at how understanding data can help us make better decisions, whether in business, healthcare, or even everyday life. I'll explain key concepts and highlight why they matter, connecting them to the bigger picture of how data influences our decisions and strategies. This module sets the foundation for everything else we'll cover, so it's important to grasp how essential being data literate truly is. By the end of this section, you'll see that analytics isn't just for data scientists. It's a vital skill for everyone who wants to navigate and succeed in a data-driven world. Organizations that embrace analytics tend to see a 5 to 6% increase in productivity and profitability. That's a significant boost, and it really highlights the proven impact that data-driven decision-making can have on a business. When we talk about impact, it's not just about numbers. It's about improving operational efficiency, uncovering new opportunities that might have otherwise gone unnoticed, and strengthening your competitive edge in the marketplace. So why does this matter? Well, analytics involves systematically analyzing data through computational methods. It's about discovering and interpreting patterns within that data, and then communicating those insights clearly. All of this helps in making smarter, more informed decisions. And what exactly is analytics? Simply put, it's the process of defining, understanding, and applying data analysis techniques. It's a powerful tool that, when used correctly, can transform the way organizations operate and compete. Now, let's talk about communicating insights. This is all about how we effectively share our findings and recommendations based on data analysis to really drive action. It's not just about having the data, but about making sure others understand what it means and how they can use it. Next, creating data is a fundamental skill. It involves generating and organizing data in a way that makes analysis possible. This includes collecting the right data and structuring it properly so that insights can be accurately derived. Understanding statistics is also key. It's about grasping the results of statistical analyses and recognizing what they imply for decision-making. Knowing how to interpret these results helps ensure we're making informed choices. Reading data is equally important. This means being able to interpret graphs, charts, and tables correctly to extract meaningful insights. Visual data literacy allows us to see patterns and trends that might not be immediately obvious. Finally, understanding data literacy concepts ties everything together. It's about building a foundational understanding of how data works, which enhances our ability to analyze, interpret, and communicate data effectively in any context. All of these skills support our overall goal of turning data into actionable insights that can truly make a difference. Now, according to Gartner, 87% of organizations have increased their investment in analytics initiatives. This is a significant shift, highlighting how vital analytics has become in today's business landscape. These investments are primarily aimed at enhancing agility and fostering innovation. In other words, companies are recognizing that leveraging data effectively allows them to adapt quickly to changing market conditions and to develop new ideas more rapidly. This trend underscores the crucial role analytics plays in modern organizations, serving as a key driver for staying competitive and responsive in a fast-evolving environment. So, as we move forward in this presentation, keep in mind that analytics isn't just a supporting function. It's at the core of strategic growth and innovation today. Let's walk through the analytics process overview. First, we start with defining and collecting the data. This involves clarifying the problem we're trying to solve and gathering the relevant data that aligns with our business needs. It's the foundation for everything that follows. Next, we move on to cleaning and preparing the data. This step is crucial because it involves fixing quality issues, standardizing fields, and making sure the dataset is analysis-ready. Clean data leads to more accurate insights. After that, we analyze the data. Here, we apply various methods to uncover patterns, identify drivers, and measure outcomes. This is where the real insights start to emerge, helping us understand what's driving the results. Finally, we interpret and communicate these insights. This means translating our findings into actionable recommendations, reviewing them iteratively, and refining our insights over time. Effective communication ensures that our analysis truly informs decision-making and drives meaningful change. Let's talk about some common misconceptions surrounding analytics. First, many people think that analytics is only accessible to experts with advanced training. But the reality is, most analytics tasks are actually approachable if you have the right tools and some proper training. This means wider adoption is possible when we make analytics more accessible. Now, there's this misconception that analytics requires complex math. That can be pretty intimidating and often discourages non-specialists from getting involved. The truth is, you don't need to be a math wizard. Analytics is much more about understanding your data and asking the right questions. Speaking of which, some believe that analytics is purely technical and only for IT professionals. But in reality, it's a multidisciplinary field. It combines domain expertise, collaboration, and critical thinking, so it's about more than just technical skills. Overall, these misconceptions can hold us back. But when we see analytics as accessible, inclusive, and collaborative, it opens up many opportunities for everyone to contribute and benefit from data-driven insights. Welcome to Module 2, where we'll explore data types and sources. In this section, we'll focus on understanding the different kinds of data you'll encounter and where they come from. Recognizing these differences is crucial because it impacts how we collect, analyze, and interpret data effectively. We'll cover the main data types, such as structured, semi-structured, and unstructured data, and discuss their unique characteristics. Then, we'll look at various data sources, like internal systems, external databases, and real-time feeds. Connecting these points to the bigger picture, understanding data types and sources helps us make informed decisions and develop more accurate insights. So, let's dive into how these elements form the foundation of effective data management. Let's take a closer look at extraction techniques for different types of data. For structured data, we typically use SQL-style queries, which are quite straightforward because the data is organized in predefined fields. On the other hand, unstructured data relies on more advanced methods like natural language processing and machine learning to extract meaningful insights. Now, when it comes to their uses, structured data plays a critical role in supporting transactions and generating reports. It's all about efficiency and accuracy. Unstructured data, however, is the powerhouse behind understanding sentiment, making recommendations, and uncovering deeper insights that aren't as easily accessible through traditional methods. As for examples, think of structured data like spreadsheets or SQL databases, where everything is neatly organized. Unstructured data includes things like emails, social media posts, and multimedia files such as images and videos, which lack a fixed format. Finally, their characteristics really highlight their differences. Structured data is stored in predefined fields, making it easy to search and analyze. Unstructured data, by contrast, has no fixed format: text, images, videos. It's much more flexible but also more complex to interpret. Understanding these distinctions helps us choose the right techniques for each type of data, which is essential for extracting valuable insights in today's data-driven world. Now, let's take a closer look at the different data collection methods we often use. We have surveys, which are quantitative, meaning they provide numerical data that we can analyze statistically. Then there are interviews, which are qualitative, offering more in-depth, descriptive insights into people's motivations and experiences. Sensors are another quantitative method, giving us measurable data like sensor readings. Focus groups, on the other hand, are qualitative and help us understand group dynamics, opinions, and attitudes. Moving on, we often combine these methods in a mixed methods approach. This means we gather both quantitative and qualitative data to get a richer, more comprehensive understanding of the subject. Using mixed methods helps us validate our findings and fill in any gaps left by using just one type of data. Now, talking about qualitative data, this is all about context, descriptions, and exploring motivations or personal experiences. Examples include interview transcripts or open-ended survey responses. It's more about understanding the why behind the numbers. Quantitative data, by contrast, is numerical and measurable. It's perfect for statistical analysis and includes things like survey scores or sensor readings. This type of data provides us with concrete, objective information. Finally, when we compare qualitative versus quantitative data, the key difference is that qualitative data provides depth and context, while quantitative data offers measurable, numerical insights. Both are crucial in research, and understanding how they complement each other helps us design better studies and interpret findings more effectively. Let's take a closer look at the limitations and benefits of data collection methods. Starting with the limitations, primary data collection can be quite time-consuming and costly. It often requires significant resources and planning to gather new information. On the other hand, secondary data, which comes from existing sources like government reports or academic publications, might not always be perfectly relevant to our specific needs. We also have limited control over the quality of that data, which can sometimes be a concern. Now, on the flip side, the benefits are quite compelling. Primary data, although more resource-intensive, is highly tailored to our specific objectives, and we can ensure a high level of accuracy and relevance. Secondary data, meanwhile, offers quick access and tends to be more cost-effective, making it a valuable resource when time and budget are constraints. It's important to understand that both types of data, primary and secondary, play a crucial role in research. Secondary data provides a good starting point and saves us time and money, while primary data allows for deeper insights and greater control over the quality of the information. Balancing these sources effectively is key to making informed decisions that support our overall objectives. Let's talk about structured data first. These are formats like CSV, JSON, and XML, which organize information into consistent fields. This consistency makes it much easier to ingest and analyze the data reliably. When data is structured this way, it's straightforward to process because each piece of information has a clear place. Now, on the flip side, we have unstructured data. Think PDFs, images, or audio files. These don't follow a fixed format, so they require extra work, either extracting relevant information or enriching the data, before we can analyze it effectively. This process can be more complex, but is often necessary given the variety of data sources we encounter. So, why does compatibility between these formats matter? Well, CSV is very common in business reporting because it's simple and widely supported. JSON, on the other hand, is popular for web data transfer because of its flexibility and ease of use in web applications. Recognizing these common formats helps us choose the right tools and methods for handling different data sources efficiently. Overall, understanding these common data formats and their roles helps us ensure smoother data integration and more effective analysis, which is central to making data-driven decisions across any organization. When it comes to reliable analysis, it all starts with disciplined source evaluation. That means we need to assess credibility, preferably using authoritative sources with well-documented collection methods. We also want to verify their reputation, incentives, and domain expertise to make sure we're on solid ground. Next, we check data currency by looking at the as-of date, how often the data is refreshed, and whether there's any lag. It's important to see if the timing aligns with our decision-making needs. Then, we evaluate accuracy by looking for measurement errors, data entry issues, and transformation mistakes. Confirming definitions, units, and calculation logic helps us avoid skewed insights. Completeness is another key factor. We should identify missing records or fields, uneven coverage across regions or segments, and be aware of survivorship effects that could distort our conclusions. We also need to consider bias potential, examining sampling methods, selection processes, labeling, and reporting biases. It's crucial to recognize whose perspective might be over- or underrepresented in the data. Moving beyond assessment, practical guidelines involve validating the data by cross-checking against independent sources, reconciling totals, and running reasonableness tests like checking ranges, duplicates, or outliers. Documentation is equally important, recording data lineage, definitions, and assumptions, and maintaining a clear data dictionary and change log to track updates over time. To control quality, we should implement automated checks at data ingestion and prior to reporting. Failed records need to be quarantined and issue resolution tracked systematically. Finally, governance plays a vital role in ensuring repeatable quality. Organizations often adopt data governance frameworks that assign ownership, define quality standards, and monitor key metrics such as data freshness, error rates, and completeness. Clear stewardship and regular review cycles help make data reliability a systematic, ongoing process rather than a one-off effort. Now, let's turn our attention to Module 3, Data Collection. This is a crucial part of any project because the quality of your data directly impacts the insights you can draw. When we talk about data collection, we're referring to the process of gathering information in a systematic way to answer our key questions. It's important to choose the right methods for collecting data, whether that's surveys, interviews, observations, or digital analytics, depending on what fits best with our goals. Remember, consistency and accuracy during collection are vital, because errors here can lead to misleading results later on. Connecting this to our overall theme, effective data collection sets the foundation for everything that follows. Without good data, even the most sophisticated analysis won't yield reliable insights. So, always keep in mind that thorough, careful collection is essential for making informed decisions and driving success. Let's take a closer look at some emerging technologies that are really transforming data collection today. Advances like the Internet of Things, or IoT, are expanding our ability to acquire data in real time, which supports more dynamic and continuous research efforts. This means we can gather information as events happen, rather than relying solely on static datasets. Web scraping is another powerful tool. It's about automatically extracting information from websites, giving us access to vast amounts of online data quickly and efficiently. This method enables researchers to analyze what's happening across the web without manual effort. Sensor data is also becoming increasingly important. Devices like IoT sensors collect data automatically, allowing for real-time monitoring of various parameters, whether it's environmental conditions, equipment performance, or human activity. This continuous stream of data helps us make timely decisions and insights. Transactional records, which are system-generated logs of purchases, financial transactions, and other activities, are invaluable for identifying behavioral patterns and trends. By analyzing these records, we can uncover insights into consumer behavior or financial health. Surveys remain a staple, especially for large-scale quantitative research. Structured questionnaires help gather opinions, behaviors, or demographic information from many participants, providing a broad perspective on the topic at hand. Lastly, observational studies involve researchers recording events as they naturally occur, without interference. This approach is especially useful for qualitative insights, helping us understand context and behavior in real-world settings. Together, these methods of data collection are central to modern research, allowing us to gather richer, more timely, and more diverse data than ever before. Let's talk about some of the key challenges we face in data acquisition. Typically, about 30% of the collected data ends up being unusable. This is often due to accessibility limits, meaning we just can't get to the data easily. Inconsistent formats also pose a big problem, making it difficult to integrate data from different sources. Privacy constraints are another major hurdle, especially with increasing data protection regulations. High costs associated with data collection and management can also limit what we can do. Plus, data often resides in siloed systems, which means different departments or teams keep their data separate, making cross-functional coordination necessary but challenging. All these factors highlight just how complex and resource-intensive acquiring clean, usable data can be. It's a critical piece of the puzzle in turning data into actionable insights, and addressing these challenges is essential for success. Let's take a closer look at some essential data cleaning techniques. First, we need to detect errors, which involves finding invalid values, type mismatches, and formatting issues. This step helps us identify problems early on. Next, we move on to removing duplicates by using stable keys and matching rules to ensure each record is unique and accurate. Then, we normalize formats, standardizing dates, units, categories, and casing so that everything is consistent across the dataset. After that, we validate entries by applying rules, ranges, and referential checks to catch any inconsistencies or outliers. Finally, we reach the impute and review stage, where we fill in missing values, assess outliers, and confirm overall consistency. These techniques are all about ensuring our data is clean, reliable, and ready for analysis, which is at the core of effective data management. Let's start by looking at erroneous values. Automated checks are great for efficiency. They can quickly flag obvious errors. However, they might overlook subtle issues that require a more nuanced approach. On the other hand, manual review is much more thorough, allowing us to catch those tricky errors, but it can be quite time-consuming and resource-intensive. Moving on to techniques for detecting erroneous values, methods like range checks, anomaly detection, and validation rules are commonly used. These help us identify errors so we can correct them and ensure data quality, an essential step in reliable data analysis. Now, when it comes to missing values, there are also pros and cons to consider. Simple techniques like deletion are straightforward and easy to implement, but they can lead to a reduction in our data size, which might impact our analysis. Alternatively, imputation methods aim to preserve as much data as possible by filling in missing values, but they can introduce bias if not done carefully. Speaking of techniques for handling missing data, common approaches include deleting incomplete records, replacing missing values with the mean or mode, or using predictive modeling to estimate the missing data. Each method has its place, depending on the context and the nature of the data. Ultimately, understanding and properly managing missing and erroneous values is crucial for maintaining data integrity. It ensures that the insights we draw are accurate and trustworthy, which ties directly into our overall goal of high-quality data analysis. Now, let's take a look at the overall data preparation process for analysis. As you can see, we've broken it down into 4 key stages. First is data transformation, where we reshape and clean fields to make sure they align with our objectives. This is an essential step because clean, well-structured data forms the foundation for accurate insights. Next is normalization, which scales values to comparable ranges, helping our models stay stable and reliable. Moving on, feature engineering involves creating informative variables that enhance our signal, making it easier to detect meaningful patterns. Finally, integration brings everything together by combining sources for consistent analysis and interpretation. This step ensures our data is cohesive and ready for the analytical tasks ahead. Overall, each of these stages plays a crucial role in preparing our data effectively, setting the stage for successful analysis and decision-making. Welcome to Module 4, where we'll explore the foundations of descriptive statistics. In this module, we'll focus on understanding the key tools and concepts that help us summarize and describe data effectively. Descriptive statistics are essential because they allow us to make sense of large amounts of data quickly and clearly. We'll cover measures of central tendency, like the mean, median, and mode, which tell us about the typical value in a dataset. We'll also look at measures of variability, such as range, variance, and standard deviation, which help us understand how spread out the data is. Throughout this module, we'll see how these concepts connect to the bigger picture of data analysis and decision-making. The goal is to build a solid foundation so you can confidently interpret data and communicate your findings clearly. So, let's dive into these foundational tools and see how they form the backbone of descriptive statistics. Let's take a closer look at some key statistical concepts. First, distributions describe how the values of a variable are spread out or clustered together. Understanding this helps us see the overall pattern in the data. Next, we have variability and uncertainty, which are about recognizing and measuring the differences and unpredictability in our data. These are crucial because they remind us that data can never be perfectly predictable. Variables are simply the characteristics or properties we measure in a study, such as height, age, or income. They give us the specific data points we analyze. Statistical inference is about drawing conclusions about an entire population based on a sample we've studied. It's how we make generalizations from our data. Now, there's an important distinction between populations and samples. A population includes all members of a group we're interested in, while a sample is just a subset, a smaller group we analyze to learn about the whole. Lastly, probabilities tell us the likelihood of an event happening, and this value ranges from 0, meaning impossible, up to 1, meaning certain. Understanding these concepts helps us interpret data more effectively and make informed decisions. Let's talk about measures of central tendency, which help us understand the typical value in a dataset. First, there's the mode, which is simply the most frequent value. This is especially useful when dealing with categorical data or when repeated values carry meaningful information. It's a quick way to see what appears most often. Next, we have the median, which is the middle value when all data points are ordered from lowest to highest. One of its strengths is that it's more resistant to skewed data and outliers than the mean. So, if your data is skewed or contains extreme values, the median gives a better sense of the central point. Finally, there's the mean, or the average, calculated by summing all values and dividing by the count. The mean is most appropriate when your data is roughly symmetric and doesn't have extreme outliers, as it can be heavily influenced by those. Overall, these measures summarize a dataset by highlighting a typical value, but each one is suited to different types of data and distributions. Understanding which to use helps us better interpret our data and draw meaningful conclusions. Let's take a closer look at measures of spread in a dataset. First, we have the square root of the variance, which is the standard deviation. The key advantage here is that it's interpretable in the original units of the data, making it easier to understand what the variability actually means in real-world terms. The standard deviation is essentially the average squared deviation from the mean, and when we take its square root, we bring that measure back to the original units. The variance, on the other hand, is calculated as the average of the squared differences from the mean. Then there's the range, which is the simplest measure of spread. It's just the difference between the maximum and minimum values in the data set. While easy to compute, it gives a quick sense of how spread out the data is. All these measures, standard deviation, variance, and range, help us quantify the variability or dispersion within our data. Understanding these concepts is crucial because they give us insight into how consistent or diverse our data points are, which is essential for making informed decisions based on the data. A foundation for many analyses, from summaries to inference and modeling, really starts here. Now, why do these tools matter? Well, frequency tables are great because they summarize counts, showing us how often each value occurs, while histograms help us visualize the shape of the distribution. They give us a quick, intuitive way to understand the data's pattern. When we look at typical formats, we're talking about understanding how often each value appears, which can reveal important patterns like skewness, whether the data leans more to one side, and modality, meaning how many peaks or modes the distribution has. These insights are crucial because they help us interpret what the data is telling us about underlying phenomena. Using frequency distributions, whether through tables or histograms, allows us to see the big picture of our data. They're essential tools for identifying patterns, making comparisons, and guiding further analysis. So, as we move forward, keep in mind how these basic summaries serve as the backbone for more complex statistical work. Let's talk about how descriptive statistics help us make sense of data for decision-making. First, remember that these summaries are useful, but their interpretation really depends on the context. Things like where the data comes from, how it's measured, and its overall distribution shape all matter a lot. Now, one key point is about the center of the data. In skewed data, like income or response times that tend to have a long tail on one side, the average, or mean, can be misleading because it's pulled toward the tail. In such cases, it's better to look at the median and the interquartile range, or IQR, to understand what's typical. However, the mean still has its uses, especially when we're forecasting costs. Next, let's consider spread or variability. The standard deviation is a common measure, but its meaning varies depending on the units you're working with, dollars versus percentages, for example. So, when comparing variability across different groups, it can be helpful to use the coefficient of variation, which is the standard deviation divided by the mean. Standardizing data before comparison helps ensure we're making apples-to-apples assessments. Finally, let's talk about outliers. Sometimes an outlier is just an error, like a sensor glitch. Other times it might be a meaningful signal, like a sudden spike in temperature or transactions. To understand these anomalies, use tools like min and max, percentiles, and grouped summaries, by time, region, or device, to localize where these spikes are happening. This helps us decide whether they're just noise or something worth investigating further. In practice, descriptive statistics are our first step in exploring data. They help us validate assumptions, spot irregularities early, and determine whether we need deeper analysis, such as data transformations, segmentation, or hypothesis testing. So always use these summaries as a foundation for more detailed work. All right, let's dive into Module 5, Data Visualization. This is a crucial part of our overall theme because, as we've seen, turning data into visual stories makes complex information much easier to understand and act upon. Here, we'll explore key points such as the importance of choosing the right visualization tools, understanding your audience, and ensuring your visuals accurately represent the data. We'll also discuss common pitfalls to avoid, like cluttered charts or misleading scales, which can compromise your message. Remember, effective visualization isn't just about making things look pretty. It's about clarity and insight. By the end of this module, you'll have a stronger grasp of how to communicate your data powerfully and effectively through visuals. Let's talk about some key principles for effective data visualization. First, accessibility is crucial. We want to make sure everyone can use and understand our visuals, including people with disabilities. For example, providing alternative text for images and avoiding relying only on color to convey information helps achieve this. Next, simplicity is important. Removing unnecessary elements helps highlight the main message. For instance, limiting the number of colors and data series keeps the visual clean and focused. Then there's accuracy. It's vital that our data is represented honestly and without distortion. A good rule of thumb is to start axes at 0 when it makes sense, so the scale is truthful and not misleading. Finally, clarity. Our visuals should communicate information clearly and without confusion. Using clear labels and legends helps avoid clutter and makes the data easy to interpret. All these principles, Accessibility, simplicity, accuracy, and clarity are essential for creating visuals that truly inform and engage our audience. When choosing the right chart, it's important to understand what each type is best suited for. Scatterplots are great for revealing relationships and outliers, but you should add a trend line only when it makes sense, such as when highlighting a clear pattern. They work well for part-to-whole comparisons with a few slices, but avoid using them for comparing across different pie charts. Pie charts, on the other hand, are ideal for showing proportions and how they change over time, especially if you keep the series count limited and use consistent intervals. Line charts are perfect for illustrating trends over time and comparing categories. Just remember to keep a zero baseline for clarity and sort the data to improve readability. Lastly, bar charts are versatile for comparisons, but choosing the right type depends on your data and the message you want to convey. Be cautious. Misusing any chart can mislead your audience, so follow best practices to ensure your visuals are accurate and effective. Let's talk about the importance of visual consistency. Keeping a unified palette helps create a cohesive story that resonates with our audience. Notice how using heritage gold accents, specifically the color D27B07, draws attention to our key points. This color acts as a visual cue, emphasizing what truly matters in our narrative. It's crucial to be consistent and highlight meaning through these accents, making sure our most important messages stand out. When designing, always aim for clarity, label data clearly, and use informative titles that explain the so what behind each point. Removing unnecessary clutter is essential, too. When our visuals are clean and straightforward, the key takeaway becomes immediately obvious. Remember, a clear and compelling visual design isn't just about looks, it's about guiding your audience's understanding effortlessly. By applying these principles, maintaining a unified palette, using strategic accents, and reducing clutter, we ensure our story is both powerful and easy to follow. Now, let's talk about some common visualization mistakes to watch out for. First, ignoring color blindness. If you don't use accessible color palettes, you risk excluding viewers and potentially miscommunicating your key message. It's essential to choose colors that everyone can distinguish. Next, excessive decoration can be a problem. Overusing colors, 3D effects, or adding unnecessary elements can distract from your main message and make your chart harder to interpret. Clarity should always come first. Then there's the issue of misleading axis scales. Manipulating axis ranges, either stretching or compressing them, can exaggerate trends or differences, which undermines the integrity of your data. Always be honest and transparent with your scales. Lastly, using inappropriate chart types can cause confusion. For example, using pie charts for time series data doesn't make sense and can lead to misinterpretation. Choosing the right chart type for your data is crucial for clear communication. Overall, avoiding these pitfalls helps ensure your visualizations are both accurate and effective, supporting your presentation's overall message. Let's talk about how visual storytelling combines data with a clear narrative arc to connect with both emotions and intellect. When we craft our story with visuals, we're not just presenting numbers, we're guiding our audience through a meaningful journey. Using sequences of charts, annotations, and interactive elements helps keep engagement high and improves retention. These visual tools act like signposts, making complex data more accessible and memorable. Ultimately, effective visual storytelling makes data more relatable and impactful, reinforcing the overall message of our presentation. Now, let's move on to Module 6, Interpreting Data. In this part, we'll focus on understanding what the data actually tells us. It's not just about looking at numbers, it's about making sense of them in a meaningful way. We'll explore how to identify patterns, trends, and outliers, which can reveal valuable insights about our work or project. Remember, interpreting data accurately helps us make smarter decisions and supports the overall goal of effective communication. So, as we go through this module, keep in mind that the ability to interpret data is a key skill that ties everything together in this presentation. Let's talk about correlation first. Correlation measures the association between two variables, meaning how they tend to move together. But it's important to remember that just because two things are correlated, it doesn't mean one causes the other. They might be related, but causation is a different story. Causation, on the other hand, requires more than just observing a relationship. It needs evidence from carefully designed experiments and control of confounding factors, those other variables that could influence the outcome. Without that, we can't confidently say that one thing causes another. Now, why does this distinction really matter? Well, misinterpreting correlation as causation can lead to poor decisions. If we assume one variable causes another without proper evidence, we might implement ineffective or even harmful solutions. That's why training on understanding this difference is so critical. It helps us make better, more informed choices. In the broader context of our presentation, understanding correlation versus causation is essential. It sharpens our analytical thinking and helps us avoid common pitfalls when interpreting data. Let's talk about some common techniques for identifying trends and outliers in data. One useful method is using moving averages to smooth out the data, which helps us see the overall trend without getting distracted by short-term fluctuations. Alongside that, box plots are great for quickly spotting outliers, those unusual data points that stand apart from the rest. Outliers can sometimes indicate data errors, but they might also reveal interesting insights worth exploring further. When it comes to trend detection, we're looking for consistent upward or downward movements over time. Spotting these patterns can be really helpful for forecasting and planning, giving us a clearer picture of where things are headed. Overall, understanding how to identify trends and outliers allows us to interpret our data more effectively, supporting better decision-making and uncovering hidden opportunities or issues early on. Let's talk about how interpreting p-values, confidence intervals, and effect sizes helps us evaluate both the statistical evidence and the practical impact of our findings. Using these three together actually reduces overgeneralization and keeps the uncertainty visible in our conclusions. First, the p-value is a measure of evidence against a null model. A small p-value indicates that the observed data, or something more extreme, would be unlikely if the null hypothesis were true. But it's important to remember that a p-value doesn't measure the effect size or tell us how likely the hypothesis is to be correct. Next, the confidence interval provides a range of plausible effects. It helps us judge the direction and the precision of our estimate. Narrow intervals suggest a more stable estimate, while wide intervals warn us that the true effect could be significantly smaller or larger than what we see. Then, the effect size tells us about the practical magnitude of the result. It's crucial to ask, is this effect large enough to matter? Even when the p-value is less than 0.05, we need to consider whether the effect size is meaningful in the real world, perhaps by comparing it to a relevant threshold like a minimum clinically important difference. Let's look at some examples. In case A, with a p-value of 0.03, an effect of plus 0.2 units, and a 95% confidence interval from plus 0.01 to plus 0.39, we see that the effect is statistically detectable but small. Whether it's practically valuable depends on if 0.2 units is meaningful in our context. In case B, with a p-value of 0.12, an effect of plus 1.5 units, and a 95% confidence interval from minus 0.4 to plus 3.4, the evidence is inconclusive, and there's high uncertainty. This means we should avoid claiming no effect and instead consider collecting more data or improving our measurement precision. Overall, combining p-values, confidence intervals, and effect sizes allows us to better understand the statistical results, balancing significance with practical relevance. It's about making more informed, nuanced conclusions rather than oversimplified statements. So on this slide, we're looking at what pattern detection really reveals in our data. Essentially, techniques like clustering, segmentation, and association rules help us uncover relationships that might not be obvious at first glance. These insights support targeted interventions, meaning we can act more precisely and they also help us build better customer profiles. Plus, they're key for spotting anomalies or outliers that could indicate issues or opportunities. Now, let's briefly touch on the core techniques. Clustering groups similar entities together, which helps us understand different customer or data segments. Segmentation, on the other hand, separates audiences into distinct groups based on specific characteristics. And association rules are about finding links between behaviors that tend to occur together, like certain product purchases or usage patterns. When it comes to the typical outputs of these methods, we're looking at things like cluster labels, segment profiles, affinity links, and outlier flags. All of these actually drive our decision-making and monitoring processes, giving us actionable insights. Overall, by using pattern detection, we're able to better understand complex data relationships, which ultimately helps us make smarter, more targeted decisions across the board. When we talk about critical thinking and data interpretation, what we're really emphasizing is the importance of analytical skepticism that can actually strengthen our conclusions. It's not just accepting data at face value. It's about actively questioning the data source, where it came from, how it was collected, and the methodology behind it. We also need to look at the assumptions that are embedded in the analysis, because those can significantly influence the results. Furthermore, critical thinking involves considering alternative explanations, thinking about other reasons why we might see certain patterns or trends, and checking for cognitive biases. These biases, if unchecked, can distort our interpretation or even cause us to have unwarranted confidence in a particular outcome. When we practice this kind of skepticism consistently, it leads to more robust, reliable conclusions. And it also helps elevate the analytics maturity of both individuals and teams, making us all better at making data-driven decisions. So, in essence, cultivating this mindset of critical thinking is essential if we want to truly leverage data effectively. Let's wrap up by focusing on the key foundations for data-driven success. First, applying data with purpose means asking better questions, measuring outcomes accurately, and ultimately driving meaningful impact. It's about being intentional with how we use data to support our goals. Next, visualizing and interpreting data is crucial. Turning complex analysis into clear, understandable insights helps us make informed decisions across the entire organization. Good visualization makes data accessible and actionable. Then, collection and cleaning are vital steps. Building reliable datasets requires thoughtful collection, careful preparation, and thorough quality checks. Clean data is the backbone of accurate analysis. Finally, data literacy empowers us all. By confidently understanding data types, their context, and what constitutes good data, we become more effective in leveraging data to support our work. Together, these foundations, applying with purpose, visualizing and interpreting, ensuring quality collection, and building data literacy, are what truly enable us to succeed in a data-driven environment.